Hello everyone. So today we will discuss about the chapter 4 which name is columns and strut. So as I told you in the previous video lecture, so columns and strut, okay, columns is the primary member of the buildings which is provided vertically, okay, to absorb the compressive loads. Okay, strut is also like that, but strut we can provide inclined in nature or vertically you can provide. Okay, so now coming to the chapter. So column means what? It is the vertical member which is subjected to the axial compressive load and that can transfer the load from the roof to the floor of the structure. And as an example, we can take the pillar in between the roof and the floor, which is provided in case of buildings. Okay, and we can take the example of piers or abutment, which is provided in the case of bridges. And secondly, strut. So strut is the inclined member that is again subjected to the axial compressive loading systems and that is supported by the hinged or pinned jointed support. Okay, so as we take the example of strut, that can be a truss. Okay, so now slenderness ratio. So slenderness ratio, that is the ratio in between the effective length of the column to the least radius of gyration, and we can use this slenderness ratio in case of solving the problems. Okay, so as per the types of column, so based on the height, the column is two types. One is long column and second one is short column. And in case of column and strut, so you have to remember these things. So what is the difference between them? So as we told you that column is the vertical member, okay, and we can provide the column only vertically, and in case of strut we can provide this inclined as well as vertical also. And as per the supports, in case of column section, both end of the column that must be fixed support. But in case of strut, so we can change the end supports, like we have to provide hinge support here. Okay. And in case of column, column can be failed out by the buckling. Okay. And the strut can be failed out by the help of crossing. And in case of column, the slenderness ratio that must be more as compared to strut. So strut, in case of strut, the slenderness ratio is less. Now coming to the some end condition which is very important in case of column sections, because it is dependent on the effective length of the sections. That means in case of column. So now if the both end is hinged, so you can see in the diagram also. So first condition is in case of column or strut, if the both end of the column or strut, one end is fixed end and another end is free end, then the effective length of the column, that will be 2 times of the actual length of the column. Okay. The second condition is both ends are hinged or pinned. So if the both ends of the column that is hinged or pinned, then the effective length of the column that must be equal to the actual length of the column. As you can see in the diagram, this is the total length. Okay, this is the loading system on the column. Okay. Now third type of condition is one fixed end and another is hinged end. So if a column having the end condition of one end fixed and another end is hinged, then the effective length of the column that must be equal to 0.7 times of the actual length of the column. And the last end condition is what? The last end condition is one end is fixed and another end also fixed. That means both ends are fixed support. So if this kind of condition is there, then the effective length of the column that must be half of the actual length. That means 0.5 into actual length. Now coming to one numerical. So here one solid round bar is there which length is 3 meter and diameter is 5 centimeter, which is used as a strut with both end hinged. So determine the crippling load and take the E is equal to 2 into 10 to the power 5 Newton per mm square. So first of all we need to write down all the data given. So here the length is how much? 3 meter. So 3 meter means 3000 mm. And the diameter is how much? 5 centimeter. That means 50 mm. And the condition is given as what? The ends are hinged. That means both ends are hinged. And we know that if both ends are hinged, then the effective length of the column is how much? Is equal to the actual length of the column. So that means effective length is equal to actual length, which is equal to 3000 mm as given in the question. So we have to calculate the crippling load, and the Young's modulus value that is given in the question is how much? 2 into 10 to the power 5 Newton per mm square. So first of all, in case of crippling load, the Euler's formula we have used, and the formula is how much? Pi square EI divided by L effective square. Okay. So here first we have to calculate the moment of inertia value, the I value. So I is equal to, as the column is round in section, okay, the cross sectional area of the column is round because diameter is given 5 centimeter. So that means I is equal to pi d fourth by 64, and the result is how much? 0.306 into 10 to the power 6 mm fourth. Now we need to put the value of Euler's formula, that is pi square EI divided by L effective square. So E value that is given as 2 into 10 to the power 5, and I value, we got the I value as 0.306 into 10 to the power 6 mm to the power 4th, okay, divided by L effective square. So L effective value as per the condition we got that 3000. So 3000 square. So by calculating all this value we got the value of how much? 67.11 kilonewton. So this is the value of crippling load of the column section as given in the question. So today this much. Thank you everyone.